Hello, in this video I'm going to solve the following problem for you, which is on the topic of trigonometric numerical calculations. Prove the following identity. Sine theta to the power of 4 plus cosine theta to the power of 4 is equal to 1 minus a half sine 2 theta to power 2. And use this to determine the exact value of the following sum. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly for the second part, the answer that you get for this sum is simply 3/2. If you are interested in more videos of this type, you can refer to the following playlist. The link to this playlist is in this PDF file, and the link of this PDF file is given below the video in the description. Okay, so let us solve the problem now. So the first thing is, actually I have given this as a hint, otherwise it is very hard to see how we should solve this problem from scratch. But now you will have a hint. But let us try to prove this identity first. So I want to know why sine theta to the power of 4 plus cosine theta to the power of 4 follows this rule. Okay, so if you don't mind, let me, for example, here I can start from the left-hand side, okay? Or from the right-hand side, it doesn't matter that much. So let me start from the left-hand side. So sine to the power of 4 theta plus cosine to the power of 4 theta can be written in this way. These are power 4s, so I can write it sine squared theta plus cosine squared theta to the power of 2. But of course you know that this is wrong, because I'm not allowed to say simply the first one squared plus the second one squared. But if I insist to write that, then I have to compensate this so that in a way I can go back here. So this is the first one squared plus the second one squared, but you know that this has also 2 times the first one times the second one, which is missing there. So to have this equality right, I have to take that off. Okay? Let us review. The first one squared, is this one correct? 2 times the first one times the second one will be cancelled by this minus 2 sine of the first one cosine of the second one, and then plus the second one squared. So what I have written here is completely correct. But why this is beneficial? Because you know this is a very famous identity in trigonometry, and that's 1. So this part becomes 1. 1 to power 2 is just 1. But what can I do here? Here I would write minus 1/2 multiplied by 4 times sine 2 theta cosine 2 theta. Okay, first of all, it is true, because 1/2 and 4 can be simplified and I get 2 back, so this equality is still valid. But what was my motive behind that? Because I compared this one and that one. I saw 1 is there. I need 1/2. I didn't have 1/2, so I put 1/2 here, but in order to compensate for this change, I have to put this 4. I cannot keep it 2. But why, again, this is useful? Because if you recognize the formula of the double angle for sine, this combination can be written as 2 sine theta. That's a product, remember. That's a product. So instead of saying 4 sine theta squared cosine theta squared, I can simply write 2 sine theta cosine theta squared. Yes, this expression is exactly that one. But then hopefully you remember that's a very famous combination in trigonometry. 2 sine theta cosine theta is sine 2 times the angle. So I would copy and paste 1 minus 1/2, but instead of this guy, I can write sine of the double angle, and I have a power of 2 here. Yes, so I started from the left-hand side. I continued. Now this is equal to the right-hand side. Okay, at least we know that this is true. But how this is going to help me to solve this problem? At least it is a good identity because it deals with power 4, and I have all power 4 here. But the problem is that this has sine and cosine, but here all of them are sines. Another hand is that I have 2 terms, here I have 4 terms. Considering 4 terms shouldn't be hard, because probably you will immediately understand, let us use this identity 2 times. One for one pair, once for the other pair, yes? But the problem is that how can I bring cosine theta in? Okay, so it is not very hard to realize what we learned about the trigonometry of supplementary and complementary angles. It is not hard to see that this angle pi over 8 and 7 pi over 8 are supplementary, because pi over 8 plus 7 pi over 8 is 8 pi over 8, which is pi. So the sum of these two angles is pi, so they are supplementary. And we know that sine of supplementary angles are equal. So sine of 7 pi over 8 is exactly equal to sine pi over 8. That's good, because instead of dealing with two different angles, now I am dealing with only one angle, okay? And the same is true with these two pairs, yes? So 3 pi over 8 plus 5 pi over 8 is again 8 pi over 8, which is again pi. So this means that sine of 5 pi over 8 is equal to sine of 3 pi over 8. Okay, so my question mark can be simplified a little bit. So instead of sine of 7 pi over 8, I put sine of pi over 8, and this term will be exactly the same as the first term, so it gives me a factor of 2. And the same is true here. So what I will do, it becomes 2 sine to the power of 4 pi over 8 plus 2 sine to the power of 4, 3 pi over 8. Of course, it is easy to see that I can factor a 2 out. I hope that you agree with me, at least we made some progress. Yes, instead of dealing with 4 angles, I just need to deal with 2 angles, yes? But the problem is that if I want to use this identity, I need 4th power of sine and 4th power of the cosine of the same angle. But both of them are still sine. But that's also easy to see what is the relation between the angles. If pi over 8, the angle for the first one, is added to 3 pi over 8, the angle to the second one, then it becomes 4 pi over 8. But 4 pi over 8 is just pi over 2, 90 degrees. So it means that these two angles are complementary angles now. And then we learn that sine of an angle is equal to the cosine of its complement and vice versa. So for example, if I want to continue by this rule of complementary angles, I can write 2, I can copy and paste this one. But instead of writing sine of 3 pi over 8, I can simply write cosine of its complement, which is pi over 8, and then I have power of 4. Then you immediately realize that this identity is really useful, because this is 4th power of sine, 4th power of cosine, and the angle is the same. So I can give the role of theta to pi over 8, and I can use that identity. I have a factor of 2, okay, and then I use the identity 1 minus a half sine of 2 times theta. This is my theta. If I multiply it by 2, it becomes pi over 4. So it becomes sine of pi over 4, and then squared, yes? So that is the final result. But of course, you know that pi over 4 is one of those famous angles that you have always access to the value of it. But I have it in my memory. Sine pi over 4, 45 degrees, is simply 1 over square root of 2. So if I put it in this, it becomes 2. 1 minus a half multiplied by, this is 1 over square root of 2. When I square it, it becomes 1/2. But 1/2 times 1/2 is 1/4. 1 minus a quarter is 3/4. So it becomes 2 times 3/4, but then it becomes simply 3 over 2. And that is the answer that we're supposed to reach at, yes? Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.